All right, so have you ever stopped to think about what's really going on behind the screens we use every day?
Well, I'm guessing most people probably don't.
Yeah, it's pretty easy to take them for granted, but the technology behind those screens is actually pretty amazing.
It really is. And at the heart of it all are these things called liquid crystals.
Liquid crystals. Okay, I'm intrigued.
They're kind of like a hidden ingredient that makes all the magic happen.
Hmm, interesting. So what are we diving into today?
Today, we're going deep on liquid crystals, those unsung heroes of the digital age.
Sounds fascinating.
It is. We're going to uncover 5 fascinating facts about liquid crystals, and trust me, they're way cooler than they sound.
Oh, okay. Like cocktail party trivia, but for science nerds.
Exactly.
I like it. All right, hit me with fact number one.
All right, so fact number 1. Liquid crystals exist in this weird in-between state of matter.
In between, so they're not quite solid, not quite liquid.
Exactly. They're like a hybrid. They can flow like a liquid, but their molecules also maintain a certain degree of order, kind of like a solid.
Okay, that's pretty wild. And this in-between nature, that's what makes them so special for displays.
Right. This unique structure makes them incredibly responsive to electric fields, which is how we can manipulate them to create images on a screen.
Makes sense. So fact number two.
Fact number 2. You're probably looking at a liquid crystal display right now.
Really? I mean, I guess that makes sense. I'm looking at my phone and my laptop is right here.
Uh-huh. LCDs, or liquid crystal displays, are everywhere. They're in our phones, our TVs, our laptops. Even some car dashboards use them.
Wow. I had no idea they were so ubiquitous. Okay, what about fact number 3?
All right, fact number 3. Liquid crystals are super temperature sensitive.
Temperature sensitive. So like if it gets too hot or too cold, they stop working.
Well, it's not quite that simple, but their phase, the way their molecules are arranged, it changes with temperature. And that directly affects how they interact with light.
Uh-huh. So that's how they control the images on the screen, by manipulating the temperature.
Not exactly. We use electric fields to control them, but temperature is a key factor in making sure they work properly.
Gotcha. Okay, I'm ready for fact number 4.
This one's pretty cool. Flexible screens. You know those bendable phones and foldable tablets?
Yeah, those are pretty mind-blowing.
Well, they're made possible by liquid crystals.
Oh, wow. I didn't realize that. So it's their flexible liquid-like nature that allows them to bend.
Exactly. It's a pretty remarkable feat of engineering.
Absolutely. All right, bring on the final fact.
Okay, fact number 5 might surprise you. Liquid crystals are being used in biomedicine.
Wait, really? Like in healthcare?
Yeah. Scientists are developing liquid crystal-based sensors that can detect biomarkers for diseases.
No way. So like they can help diagnose illnesses.
Exactly. And because they're so sensitive, they have the potential to detect diseases very early on.
That's incredible. So we got these 5 fascinating factoids. Are we ready to dive a little deeper?
Absolutely. Let's unpack this a bit further.
Okay. So first things first. What exactly is a liquid crystal? Like at a molecular level?
All right, well, imagine a substance that's kind of like a liquid,
Okay.
but not entirely. It also has some of the structural order of a solid.
So they're not just a random jumble of molecules.
Right. The molecules are arranged in a specific pattern, and it's this unique combination of order and fluidity that gives them their special properties.
Hmm. So are there different types of liquid crystals?
There are actually
Yeah.
several different types, each with its own molecular arrangement.
Like what?
Well, there are nematic liquid crystals.
Nematic.
Yeah. In these, the molecules are all roughly parallel to each other, but they can still move around.
Okay.
And then there are smectic liquid crystals.
Smectic.
Yeah. These ones are a bit more organized. The molecules are arranged in layers.
Gotcha. So it's more complex than I initially thought.
It is, but it's this complexity that makes them so versatile. And ultimately, it's what allows us to use them to create the displays we rely on every day.
Okay, so how do these different types of liquid crystals actually translate into the displays we use?
Well, most LCDs, the ones in our phones and TVs, they use nematic liquid crystals
Okay.
because they're relatively easy to control with electric fields. And remember, the key to a display is the ability to manipulate how light passes through the liquid crystals.
Right. So we can control them with electric fields, but how do we actually make them change their orientation to create the images we see?
That's where things get really interesting. It all comes down to the interaction between liquid crystals and, well, remember those polarizing filters we talked about earlier?
Yeah, you mentioned that they sandwich the liquid crystals.
Exactly. And those filters play a crucial role in how the display works. When there's no electric field applied, the liquid crystals are naturally aligned in a way that allows light to pass through both filters. So the pixel appears bright, but when we apply an electric field,
Wait, let me guess. The electric field causes the liquid crystals to twist, and that twisting blocks the light.
you got it.
Whoa, that's cool.
And by controlling the electric field applied to different areas of the LCD, we can create patterns of light and dark pixels forming the images we see.
So each pixel is basically a tiny shutter that can either be open or closed, depending on the electric field. That's pretty ingenious.
It really is. And it's all thanks to the unique properties of liquid crystals and their responsiveness to those electric fields.
This is amazing. I never would have guessed
Yeah.
that something so simple could be behind the screens we use every single day.
And we haven't even gotten to the temperature sensitivity yet. Remember how I mentioned that plays a big role too?
Yeah, you said that.
Well, temperature is crucial for LCD design because it can actually change the phase of the liquid crystal.
The phase.
Yeah, remember those different arrangements of the molecules. Too much heat and the crystals become too disordered, making the image blurry.
Okay, what about if it's too cold?
Too cold, and they can become too rigid, which slows down the display's response time.
Ah, I see. So it's got to be just right. Like Goldilocks.
Exactly. Engineers have to calibrate the temperature very precisely to ensure the liquid crystals are working in that sweet spot, that perfect balance between fluidity and order.
That's so cool. I'm starting to really appreciate all the science and engineering that goes into these things.
And we're only just getting started. There's a whole world of exciting developments happening with liquid crystals, especially with flexible displays and those biomedical applications.
Okay, I am definitely intrigued. Let's move on to those next.
So we've talked about how electric fields can manipulate these liquid crystals, to control the passage of light and create those light and dark pixels.
Yeah.
But how do we go from just black and white to all those vibrant colors we see on our screens?
That's a good question. Liquid crystals themselves are transparent,
Yep.
right? So where does the color actually come from?
Well, the secret is a clever combination of liquid crystals and a backlight system. Behind the LCD panel, there's a backlight
Okay.
that emits white light, which illuminates the entire screen.
Right.
And then this white light passes through the first polarizing filter and then through the layer of liquid crystals.
Right, and that's where the electric field comes in, twisting those crystals to either block or allow the light through, right?
Exactly. But that still doesn't explain the color, does it?
Yep.
Well, here's the key. Each pixel on your screen, it's actually divided into 3 subpixels.
Pixel.
Yep. And each subpixel has a color filter in front of it. Red, green, or blue.
Like the primary colors of light.
Exactly. And by controlling the electric field applied to each subpixel, we can control how much light of each color passes through.
So it's like mixing paint, but with light.
You got it.
Okay. So if all 3 subpixels are fully illuminated, we see white. If only the red subpixel is on, we see red. And by varying the intensity of each subpixel, we can create all sorts of shades and hues.
Precisely. It's a remarkable feat of engineering. By adjusting the intensity of each of those subpixels, we can create millions of colors, making those digital worlds so vibrant.
It really is amazing when you think about it. Okay, so we've covered the basics of how LCD technology works. How those liquid crystals bring those colorful images to life. But what about the future? You mentioned flexible displays earlier. What are some of the challenges in making these bendable screens a reality?
Well, flexible displays are a fascinating area of research, but there are definitely some hurdles to overcome. Traditional LCDs use glass substrates,
Right.
which are, as you know, brittle and prone to cracking. So we need to find a material that's both flexible and optically transparent.
I imagine durability is a big concern, too. I mean, these screens would need to withstand a lot of bending and flexing, right, without, breaking down.
Absolutely. Durability is key. Researchers are exploring all sorts of materials like plastics, thin films of metal. Each has its own set of challenges.
Right.
It's all about finding that sweet spot between flexibility, transparency, and durability.
What about the liquid crystals themselves? Do they behave differently in a flexible display?
That's another challenge. Maintaining that precise alignment of the liquid crystals, even when the display is flexed or bent, It's really important.
Uh,
We need to make sure that electric field can still effectively control their orientation, even in a flexible environment.
so it sounds like it's not just about finding the right materials, it's about redesigning that entire system for flexibility.
Exactly. It's a multidisciplinary effort involving chemists, physicists, engineers, all working together.
Well, it sounds like they're definitely up for the challenge. Now, let's shift gears a bit and talk about those biomedical applications we touched on earlier.
Mhm.
Using liquid crystals to diagnose diseases, it sounds almost too good to be true. How does that actually work?
It's a cutting-edge field, for sure. And the
Mhm.
possibilities are really quite remarkable. We've talked about how liquid crystals respond to temperature, right? Well, they can also respond to other stimuli, like, for example, the presence of specific molecules in a solution.
So they can act as sensors, basically.
Precisely. And that's what makes them so promising for diagnostics. Imagine, like, a liquid crystal sensor designed to detect a specific protein
Okay.
that's associated with a certain disease. When a sample, like, say, blood or saliva, comes into contact with that sensor.
Okay, so if that protein is present, the liquid crystal changes its orientation, and then you know that disease might be present.
Exactly. And because liquid crystals are so sensitive, they can detect these biomarkers in incredibly small amounts,
Wow.
which could allow for very early disease detection.
That's amazing. Early detection is so important for so many conditions. What other possibilities are there for these liquid crystal sensors?
Oh, the applications are incredibly diverse. Researchers are exploring their use in everything from detecting pollutants in the environment to monitoring food spoilage.
Wow.
Their sensitivity and versatility make them incredibly valuable for all sorts of sensing applications.
I never would have imagined. Okay, but let's get back to diagnostics for a second.
Right.
How are these liquid crystal sensors actually used in practice? Like, how do you go from a liquid crystal changing its orientation to, an actual diagnosis?
It all comes down to reading the signals.
Okay.
Liquid crystal sensors typically work by changing their optical properties.
Like color or brightness.
Exactly, in response to that specific stimulus. And researchers have developed some pretty sophisticated methods for reading and interpreting those signals.
So it's not as simple as just looking at a sensor and seeing if it's changed color.
Not quite. It often requires specialized equipment and expertise to really interpret those signals accurately.
But imagine a future where you can just use a simple at-home device to analyze a drop of your blood or saliva and get an instant diagnosis.
That's the kind of transformative potential that liquid crystal sensors hold. They could really democratize healthcare, put more control on the hands of patients.
It's really exciting to think about all the possibilities. We've covered so much ground today, from the basic science behind liquid crystals to their applications in displays and diagnostics. Where do you see this technology going in the future? What breakthroughs are on the horizon that have you really excited?
Oh, the future of liquid crystal technology is incredibly bright. One area I'm particularly excited about is the development of holographic displays.
Holograms,
Yeah.
like those 3D images you see in sci-fi movies.
Exactly. Liquid crystals have the potential to make those holographic displays a reality.
Wow.
Remember how we talked about how electric fields can precisely control the orientation of liquid crystals?
Yeah.
Well, imagine using those electric fields to manipulate light in a way that creates, like, true 3D images that appear to float in space.
That would be amazing. No more clunky 3D glasses. We could have holographic video calls, interactive games, even 3D movies that look and feel totally real.
The possibilities really are endless.
So what other advancements are you looking forward to?
Another area that I find really fascinating is the development of liquid crystal-based smart windows.
Heart windows.
Yeah. These windows could adjust their transparency in response to changes in light or temperature.
Oh, wow.
Like, imagine a window that automatically darkens on a sunny day to keep your home cool, or lightens on a cloudy day to let in more natural light.
That would be incredible for energy efficiency.
Exactly. It's all about creating a more responsive and sustainable built environment, using the unique properties of liquid crystals.
It sounds like we're on the cusp of a whole new era of liquid crystal innovation.
I truly believe we are. As scientists continue to explore the possibilities of these incredible materials, I have no doubt we'll see even more groundbreaking applications emerge, transforming the way we interact with the world around us.
Yeah, it really is amazing to think about how far liquid crystals have come from, those early lab experiments to revolutionizing displays and now, potentially changing the way we diagnose diseases.
Absolutely. It's a testament to the power of basic research and scientific curiosity. Scientists were initially just fascinated by these strange materials. They didn't fit neatly into the categories of solid or liquid, and now those early investigations have led to some of the most impactful and widespread technologies we have today.
It really makes you wonder what other discoveries are out there just waiting to be made.
Huh.
What other seemingly simple things could hold the key to amazing new technologies.
Exactly. I mean, we've talked about how liquid crystals are harnessed in technology, but they're also found in nature, right?
Oh, that's right. I remember reading about that. Nature always seems to be one step ahead.
It does, doesn't it? So certain biological structures, like cell membranes, they actually exhibit those same liquid crystalline properties.
Really? So the same science that powers our smartphones is also at work within our own bodies.
It is.
That's wild. What are some other examples of liquid crystals in nature?
Well, think about the iridescent colors of, some bird feathers or, the wings of butterflies, those vibrant shifting colors.
Yeah.
They're often produced by structures that have those liquid crystalline
And so
properties.
those dazzling displays of color that we see in nature, they're partly due to the same science that makes our screens glow.
They are. It's like this hidden connection between the natural world and the technology that we create.
It really is. And it makes you wonder what other secrets are hidden within those seemingly simple liquid crystals. What other applications might we discover in the years to come?
Who knows? Maybe we'll find ways to harness them to, create artificial photosynthetic systems,
Hmm.
to mimic nature's ability to convert sunlight into energy.
Oh, wow. Or maybe we'll even develop self-healing materials inspired by those liquid crystalline properties in biological structures.
The possibilities are truly limitless.
They really are.
Mhm.
Liquid crystals have already proven to be so versatile. And as our understanding of these materials deepens, I have no doubt that we'll unlock even more amazing applications. Applications that could transform the way we interact with the world around us.
Absolutely. And it all starts with curiosity and a willingness to explore the unknown.
Well said. Well, listeners, we hope you've enjoyed this deep dive into the fascinating world of liquid crystals. It's clear that we've only just scratched the surface of what's possible with these materials, but we hope this episode has sparked your curiosity and given you a glimpse into the incredible science behind your screens and so much more.
And who knows, maybe one of you listening will be the one to unlock the next groundbreaking application for this truly remarkable material.
Until next time, keep exploring.